Hello everybody. So we finally reached chapter 7. In chapter 7 we're actually going to talk about electrodynamics, which I think the book is as a great choice. The choice for the book's name is great because it's an introduction to electrodynamics, and in fact we spent 6 chapters introducing electrodynamics. Anyway, let's dive into it. So we have that our current density J, which is a vector, is equals to a constant times our force per unit charge. So our force, first of all, I'm going to write small f and I'll explain why in a second. Now, capital F is equals to Q times plus V cross B, right? Well, if we have our force per unit charge, we're just going to have this part right here. And we're going to call it little f. Of course, though, we can substitute this in here, and so we have our constant times this part over here. Now, usually, the magnetic field is equals to 0, so we can just think about it as our constant times the electric field. How does this constant change? Well, for conductors, we can say that our constant approaches infinity, and instead for insulators, now of course these are not realistic measurement, but just for you to understand it better, for insulators it approaches 0. That's pretty easy to realize. Remember that this is not our surface charge like we saw in chapter 6. Unfortunately, as the book mentions, there is not enough letters to be used, but that's all they have right now. This is pretty much what you need to know. And one more thing, actually, is that this formula right here is what's called Ohm's law, which is going to become pretty important in the future. I hope that was helpful, and I'll see you again in example 7.1.